Okay, this lesson is for Mrs. Cucci's College Now pre-calculus class. We're on lesson 7.3c, which is the powers and roots of complex numbers. Okay, so what we're going to do, remember last time we did multiplication and division, and exponents, or the powers, is nothing more than repeated multiplication. So we're going to use that to figure out a general rule for raising a complex number to a power. So to do that, we're going to take a look. We're going to have, let's say we have a complex number. We're in trigonometric notation. R cosine theta plus I sine theta. And what we're going to do is we're going to find the square of this number. So instead of writing it like this, remember squaring is multiplying something by itself, so I'm going to multiply our complex number times itself. Cosine theta plus I sine theta. Now I use my multiplication rule that I learned last time. So we're going to end up with R times R cosine of theta plus theta plus I times the sine of theta plus theta. Yeah. Okay. So we'll do a little simplification here. And R times R is going to be R squared. Cosine theta plus theta is, of course, 2 theta plus I sine 2 theta. And this right there is going to be whenever you're squaring a complex number written in trigonometric notation. Similarly, if we look at the complex number, same complex number we had last time, R cosine theta plus I sine theta. We can imagine this being written 3 times out, so we're going to take this and multiply it by another one, and we end up with R cubed cosine of 3 theta plus I sine of 3 theta. And what we're going to see is we're going to get a general rule that any complex number R cos theta plus I sine theta, when you raise this to the n power, the general n power we're going to get, the answer is always R to the n times the cosine of n times theta plus I times the sine of n times theta. This is our general rule. So let's take a look at an example. Let's say we had 1 plus I, and we want to raise it to the 9th power. First, we're going to use the stuff we learned on 7.3a to convert that into trigonometric notation. And if you look back at 7.3a, you'll see we actually done this one already. We used it a couple times, and it was radical 2 cosine of 45 degrees plus I times the sine of 45 degrees and we're going to be raising this number to the 9th power. Okay. So we look at our general rule and we see we have to take r and raise it to the n. So we have radical 2, radical 2, and we're going to raise that to the 9th, times the cosine of 9 times 45, n times theta, plus I times the sine of 9 times 45 okay. And now we just have to do a little bit of simplification. Remember, the one radical is to the 1/2 power, so this is really 2 to the 9/2 times cosine of 9 times 45, which is 405. So the cosine of 405 degrees plus I times the sine 405 degrees. A little more simplification. 405 has a reference angle of 45 degrees. So we can simplify this in here to think of it as cosine of 45 degrees plus I times the sine 45 degrees using our reference angles. And also 2 to the 9/2 power is going to simplify to being 16 radical 2 when you do out the simplification of a radical. And so last but not least, we'll just clean this up. 16 radical 2. Cosine of 45 is radical 2 over 2. Sine of 45 is radical 2 over 2. Don't forget to multiply that one by that I. And we get our final answer to be, when you do this distribution and rationalization, you're going to get 16 plus 16i. Okay, so let's take a look at one more of these. Say in this example we have radical 3 minus I. And we're going to raise this to the 10th power. So the first thing we need to do is do our conversion to trigonometric notation. And when you do that, we did this one also in 7.3a, and this came out to 2 times the cosine of 330 degrees plus I times the sine of 330 degrees. This is all being raised to the 10th power. Okay, so we have this. We have 2 to the 10th using our rule here, which is r to the n, so 2 to the 10th. Cosine of 10 times 330 plus I times sine of 10 times 330. Okay. Keep going 2 to the 10th. It's 1024 times the cosine of 3,300 degrees plus I times the sine 3,300 degrees. 3,300 degrees has a reference angle of 60 degrees. So we can think of this as 1024 times the cosine of 60 plus I times the sine 60. And of course that's 1024. Cosine of 60 is 1/2. Sine of 60 is radical 3/2. Don't forget to multiply that by I. And we're going to do our distribution. And we get 512 plus 512 radical 3 times I. And that's going to be our answer. Okay. Now we've talked about powers. Of course, the opposite of a power is a root. And we can do just the same thing here. Remember, a root is just a exponent that's a fraction. So say we have a complex number, our general complex number written in trigonometric notation again, our cosine theta plus I times sine theta. And say this time we want to raise this to the 1/n power. Okay, and this is going to equal, now bear with me here because this is a fairly long formula, r to the 1/n times the cosine of theta divided by n plus a number k, which I'll define in a second, k times 360 degrees all over n, plus I times the sine of that same new crazy angle, theta over n plus k times 360 degrees over n. That's the formula. Okay, now this formula, as well as the other formulas, you might want to consider putting these on a note card, just like we did with the trig identities, so you don't have to memorize them. Okay, so let's put this formula in action and see an example of it. Let's try finding the square root of 2 plus 2 radical 3i. Two plus 2 radical 3i. And we're finding the square root, so we're raising it to the 1/2 power. Okay, so we're going to rewrite this using the formula. Have we done this? We have not done this in class, but I'm going to go ahead and just do this in the interest of time. Instead of writing this, we're going to write it in trigonometric notation. It's going to be 4 times the cosine of 60 degrees plus I times the sine of 60 degrees. Okay, written in trigonometric notation. Now at this point, when we're doing complex numbers, it's helpful to write out some things we know. We know that n equals 2, or to the 1/n power, n equals 2. We also know that since n equals 2, 1 over n is 1/2, 1/2. We also know this value for k. Now k, it appears in the formula over here. K can be any number, or most of the time multiple numbers, starting at 0 and ending at n minus 1. So in this case, n is 2. So k could be 0, starts at 0. Next one is 1, and that's n minus 1. That's 2 minus 1 is 1. So k can be 0 and 1. There are two roots. Keep in mind, if I'm raising something, something squared has two roots. Something to the radical 2 has two roots. To the radical 3, 3 roots. To the radical n has n different roots. That's why k is going to have 0 to n minus 1. So you always try to figure that out. It's just helpful to write down these three. Okay. So now we can go ahead and just apply our formula. So we have our trigonometric formula. Remember, we're raising it to the 1/2. 4 cosine of 60 plus I times the sine of 60 to the 1/2. We're going to apply our formula, and so when we plug in, we're going to have 4 to the 1/2 cosine of 60 divided by 2 plus k times 360 over 2 degrees plus I sine of that same new angle, 60 over 2 plus k times 360 degrees over 2. When k equals 0, or, whoa, sorry about that. When k equals 0 or 1. Okay. And now all we have to do is simplify. 4 to the 1/2 is radical 4, that's 2. Cosine of 30 plus k times 180 degrees. That's the angle for cosine. Plus I sine of 30 plus k times 180. When k, as we stated earlier, is 0 or 1. Use commas to show that. Okay. This means we have two cases. We have two different roots. So the roots are 2 times the cosine. So this time I'm going to plug in 0. So if I plug in 0, k times 0 times 180 is 0. I just have cosine of 30 plus I times the sine. Plugging in 0, 0 times 180 is 0. So we have the sine of 30. And that's just going to equal 3 plus I. 3 plus I. When you convert this back to standard notation, or you could leave it in trigonometric notation, whatever the question is. The second root, plugging in 1 for k, we have 2 times the cosine. 180 times 1 is 180, plus 30 is 210, so the cosine of 210 degrees, plus I times the sine 210 degrees. And if you were to convert this back, once again using the techniques we learned in 7.3a, we get that this is 3 minus I. Okay, that's all the time we have for you today. Sorry, this is negative radical 3 minus I, and this is radical 3 plus I. That's all the time we have for you today. See you again next time. Make sure you bring all your questions to class.